Welcome to the Explainer. Today, we're going to tackle something that looks, really intimidating, but is actually built on a concept you've known for years. Adding and subtracting rational expressions. Seriously, if you can add fractions, you can totally do this.
So here's how we're going to break it down. We'll start by connecting this to simple fractions, then we'll get into the nitty-gritty of finding a common denominator, building up our expressions, and putting it all together. And you'll want to stick around for the end because we're going to cover the #1 mistake people make. Okay, let's dive in.
All right, so what's the big secret to all this? Well, the secret is there is no secret. A rational expression is just a fancy way of saying a fraction with variables in it. All those rules you learned way back when for adding fractions, they apply here, 100%.
Just look at this. On the left, you've got a basic arithmetic problem, without even thinking that you need a common denominator. Well, guess what? The problem on the right is exactly the same idea. Yeah, it looks a little scarier with the x's in there, but the core principle? It's identical. And that's all a rational expression is. Don't let the term throw you off. It's just a fraction that's got some algebra in it. Simple as that. Okay, on to the first major step. Finding that least common denominator, or the LCD. This is our secret weapon. This is how we're going to take those messy, complicated-looking expressions and make them play nice together. And the key to the whole thing, the absolute most important action you will take, is this. You have to factor. Why? Because factoring is like looking at the DNA of your denominators. It breaks them down into their basic building blocks, so you can see exactly what you're working with. And the process is always the same, just 4 steps. First, you factor everything down as far as it can go. Then you make a list of all of the unique factors, every different piece you see. Now, if a factor shows up more than once with an exponent, you always grab the one with the highest power. And finally, you just multiply that collection of factors together. That's it. So let's get our hands dirty with a real example. We need to find the LCD for these 2 denominators. As they are right now, they look totally unrelated, right? But watch what happens when we do step 1, factor them. All of a sudden, things become much clearer. You can immediately see they actually share a common piece, but x plus 1. So when we make our list of unique factors, we've got x minus 3, x plus 1, and x plus 3. None of them have any exponents to worry about, so we just list each one a single time. And to get our LCD, we just multiply those unique pieces together. And there it is. This is the common denominator we're going to use to bring our 2 original fractions together. Okay, so we found our LCD. That was the hard part. Now we just need to get our original fractions ready by rewriting them so they both have this new denominator. And the way you do that is by asking one simple question for each fraction. What's missing? What piece does its original denominator need to look exactly like our new LCD? You can see it laid out here. For that first fraction, the missing piece was x plus 3. So we multiply the top and bottom by x plus 3. For the second one, the missing piece was x minus 3. Now, the key here is that we're basically just multiplying by the number 1, right? Anything over itself is 1. So we're not changing the value, we're just changing how it looks. And now, the moment we've been waiting for, the payoff. All that prep work is done, and we can finally combine our fractions into 1. This part's pretty straightforward. You just add or subtract the numerators and put the whole thing over that one common denominator we worked so hard to find. And a little tip, leave the denominator in that factored form for now. It'll come in handy later. Next, all our focus goes to the numerator. We just need to clean it up. Distribute everything out, combine all your like terms, and get it into one nice, clean polynomial. Okay, now here's a really, really important piece of advice. You might see a factor on top that looks like 1 on the bottom and get tempted to cancel it out right away. Don't do it. Avoid that temptation. Wait until you have one single, fully simplified numerator before you even think about canceling. And that brings us to the final check. Once the numerator is simplified, you see if it can be factored. If it can, and if it shares a factor with the denominator, now you can cancel. In this case, our numerator is prime. It can't be factored, so that means we're all done. The expression is fully simplified. Before we wrap this up, there is one more thing we absolutely have to talk about. I call it the subtraction trap, and it is without a doubt the single biggest pitfall with these kinds of problems. This is so important.
When you're subtracting one rational expression from another, that minus sign applies to the entire second numerator, every single term, not just the first one. Forgetting to distribute that negative is the most common error by far.
I mean, just look at the difference here. On the left, in the incorrect version, the negative was only applied to the 4 by 4. But on the right, you see that subtracting -4 is the same as adding 4. It completely changes the final answer. It's a small detail with a huge impact. So here's my pro tip. The best way to avoid this trap every single time is to just rewrite the problem. Change subtraction to adding the negative. This little habit forces you to put parentheses around that second numerator and distribute the -1 correctly every single time. It's a game changer.
You know, learning this isn't just about solving some random algebra problem. This is a fundamental skill. Mastering this unlocks the ability to solve way more complex rational equations later on. It really is a key step to becoming fluent in the language of algebra.